Hello everyone and welcome back to CBSE Tech Talks. In today's session, we will explore data handling in Python, one of the most important fundamental topics in programming. Before proceeding further, let's see what will be learning outcome of this session. By the end of this session, you will be able to identify and use Python data types. You will be able to differentiate between mutable and immutable types. Will be able to apply various operations in Python and will be able to write and evaluate expressions. When we talk about Python, it supports many data types and they are numbers. Numbers are int, float and complex, string, list, tuple and dictionary. Let's start with integers and let's deep dive into other data types also. When we talk about numbers, it is integer, that is whole number, positive or negative. I will be showing you even the effect how the things are done. Let me open Python. So when we talk about integer, let's take an example. Suppose I write a equals to 10, b equals to minus 25. Now if I write the type, if I want to get what is the type of a and what is the type of b, I will write print. We have type function, inbuilt function, which will return the type of the identifiers or the letters you are passing. So in this case it is type of integer. Now if I write, even if I want to know the type of b variable or identifier, so print type and b, so it is going to again give you int. Now when we talk about Python, we have booleans are also taken as you can say integers. True is 1 and false is 0. Now when we talk about true and false, the T of true and F of false to be in capital, then only it will be taken as boolean values. So if I write print true plus true, it is giving you value 2 because 1 true is 1, 1 plus 1 it gives you 2. So if I go with the other value, now in this case it should give you answer as false is 0, 0 plus 5 is 5 only. I think this is clear now. Now the next one is a floating point. When we talk about floating points, a floating point or is a number having fractional part as a floating point number. The decimal point signals that it is a floating point number. Let's take an example. If I write 12, let's see equals to 12, and if I write print type C, it is going to give me integer. But the moment I write, let's write d equals to 12.0. And if I will try now the type of this variable, or you can say identifier, I'm going to get as float because it is having decimal point now. It means decimal point is must. Regarding floating point, already the previous video is uploaded where we have the floating point in depth. Now when we talk about floating point, we have some advantages also. They can represent values between the integers because from, let's take an example, from 1 to 2 there can be thousands of values, 1 point something that way. So we are able to represent more values. As they are able to represent between the integers, so they are able to represent greater range of values. But there is one drawback also, and the drawback is nothing much, but as it is taking floating values, so the calculation or the operations become slower as compared to integers. That's only one difference, or you can say one drawback. Now let's move to the next one. I have explained you integers, I have explained you floating point. So they have fractional or the exponent, and we have double precision, that is take the fifth digit 15. Now the next one is complex number. When we talk about complex number in Python. First of all, I want to tell you this is the language where complex numbers are handled. Now, we know that complex number is nothing but the square root of minus, or you can say square root of negative integers. Now, in mathematics, if you know iota, we use iota, that is I, to represent complex number. But this is not confined to only mathematics subject. Even we handle Python for electronics, for physics, for electrical engineering, and so many. So instead of using I, because I there is used for current, so the J is used here. So J is nothing but the square root of -1. Now we have two functions here, that is real and image. So we can find out the real part and the imaginary part of any number. So let's take an example. I'm writing again, I'm showing you how to go with. Today we have not much to do on, so I'm doing in the interact mode only. Otherwise you can go with the script mode. Let me make the screen of size so that both things can go simultaneously. Now let's take an example. Suppose if I write z equals to a plus 3j. So we know, I told you that j is representing here the imaginary part. So you can get the values, print j dot, we have function real. So real is one function. So the moment you will write, it is going to give you 10 here. Now what is a 10? The value of a was given somewhere. I gave some other value there, the value of a. So it is taking that way. Let me give the value of, again the value of variable z as 2 plus 3j. Let me write this way because it took some other value. Now let me write print j dot real part. I want to get the real value from this. So you are getting 2 as a real value. Now in the previous case when I use a, somewhere I use a as 10. So that's why it was giving us 10. So don't be panic, don't get confused. So the value of a was taken that way. Now here the value expression is z equals to 2 plus 3j. So 2 is the real part. Let's check for the imaginary part. So again we will be writing print z dot imag. So this is going to give the imaginary part, that is 3.0 is the imaginary part. J is representing -1. So I think it's clear. Now let's move on to the next data type, that is string. Now basically string is nothing but the sequence of characters enclosed in quotes. Quotes may be single or may be a double. Now it can hold any type of character. It can be number, it can be literal, or you can say special characters, it can be letters also. They are indexed and immutable. When we talk about index, it means each element can be individually accessed using index. Index is also known as subscription in some of the programming languages. Is the numbered position of a letter in the string. Means what is the position of number. And Python index starts with 0. Okay, and onwards in the forward direction, and if we go with the backward direction, it will start with minus. Let me show you some examples before moving to the practical portion. If I write, let's take an example, Python. If Python is a string, so P, the position of P is 0, the position of Y is 1, position of T is 2, position of H is 3, position of O is 4, and position of N is 5. This is in the positive, or you can say forward way. Now when we talk about it means the length or index of the string is going from 0 to L minus 1, length minus 1. What is the length of Python? P 1, 2, 3, 4, 5, 6. So it is 6 minus 1. 6 minus 1 is 5. Now when we go toward the reverse way, the index of N is minus 1, minus 2, H is minus 3, T is minus 4, Y is minus 5, and P is minus 6. So if we go in the reverse way, so it starts with minus 1 and it goes to minus length. I think this is clear. So we can go with the forward indexing, we can go with the reverse indexing also. And these are immutable. It means you can't change the value, or you can't change the character. Suppose I want, instead of the variable, you can say y, I want some other character or something else here to be to change, so that will not be applicable. Let's try on ideally. Let's take an example. If I write string as Python only, name equals to suppose I'm writing Python. So I can go with the index I told you. I want h to be displayed. So the position of h is 0, 1, 2, 3. So I want third, you can say index at the third place. So it is giving h to us. Now if I want the negative way, suppose I want o is -1. So even I can go with, you can use these, you can copy and paste also, and you can write also, that you all know by this time. Name -2 I want. So it is going to start from the negative and it is going to give. So it is giving me the location as O. Now as I told you, these are immutable. If I want to change name, I want to, instead of y, I want x. So y is place 0, 1. So it is one place. So I want at one place name 1 equals to, let's take an example. I want x to be displayed. It is giving an error message. String object do not support item assignments. So it means it is not permitting you to assign the values, or it is immutable. Let's move to next topic, or the next data type, list. Now what are lists? Lists are ordered mutable collection. It is and the values are separated by commas and support different, all the values need not to be of same type. Let's take an example here. 10 is the first, you can say, element of list, hello is second, and 3.14 is third. 10 being integer, hello being string, and this is float. So this complete is making one list. The thing is that list is always in the square brackets. Now one more thing before moving to the example, I want to tell the list and tuples are Python's compound data types. They are basically the same with one difference only. And what is the difference? Lists can be changed, can be modified, or they are mutable, while tuples are non-mutable, or you can't change them or you can't modify them. Let's take an example. I will be taking this example only, and we can go with the change. So I want list equals to, and I'm writing same value what is on the screen. I want hello to, and then the third value is 3.14. So if I will write simply, okay, now here an error message has come. The reason being, hello, in the beginning I have used double quotes, while at the end I have used single quotes. So this have been informing, I explained you in the previous, I have been informing you, I have been explaining you that the starting and the closing quotes to be of same type. Now it is not giving an error message. Let's take an example, print. I want to print list. List ka I want the element at index 1. So according to you, what should be displayed? Hello is the, you can say the content at position 1. Okay. Now I want to change. As I have told you just now, it is mutable. So I want to change, instead of hello, I want to write hi. Let's see, is it working? Okay. Let's print also. You can simply write print list. It is giving an error message because you are calling print. Print is a function. In some versions of Python, print is working without parentheses, but with the latest version, print should have parentheses after it, and then I'm printing the content value of list. So it has given me 10, 30, sorry, high and 3.14. So it is changing the value. You are able to mutable. It is mutable, so you are able to mute the value or change the content. Next one is tuple, order immutable collection. Now the difference is, tuples are in small brackets, or you can say parentheses, while list is in square bracket. That is one difference of representing the value. Second difference is that tuples are immutable while list is mutable. We can try, if you want, I can try this again for you. Are we able to mute the value or not? Let's take an example. I'm writing t equals to, okay, print t is working. It is giving the value. Now I want I want to change world as, index is always in the square bracket. So t equals to, I want to change the value of TS, let's take Python. Okay. Track must recent call last file line 1 in module. Tuple object do not support item assignment, means you can't assign the values to the tuples. We can't go with that. Now the next, I think this is clear. The complete chapters, list, tuple, strings, dictionary are there in our syllabus. So I will be making, you can say, videos for that also. So don't be panic. So this is only basically on the data handling. So which type of data do Python support? This is more emphasizing on that. Next, let's move to dictionaries. Now, what are dictionaries? It is an unordered set of comma separated, that is key and value pair within curly brackets. So, dictionary will be in the curly brackets. Now, in a dictionary, no two keys can be same. It means, like in this case, if you see the example, name is one key and the value of name is John. The other key is age and the value of age is 25. So we can have John and 25 values of n number of keys, but key name and age can't be repeated. So name and age will be once only. You change small or capital, that then it will be different key, because Python is case sensitive. It will take that way. But exactly n capital and a m small can't be used again and again. String list, tuple and dictionary are iterable. It means they can return its members one at a time. You can abstract one value from all these data types. Now the next one is mutable versus unmutable types. When we talk about immutable, are those that can never change their values in place. In Python, integer, floating point numbers, Boolean, strings and tuples are immutable. Let's take an example here. If I write x equals to hello, and if I write y equals to x dot replace, I want to replace h which I have used by j. Okay, let me put of same type only, and then I want to print the value of x, and then I want to print the value of y also. Now if you see here, the value of x, what we have replaced, it is not replacing, but we can assign to some other variable. So the value of y is jail, because we have used hello jail, we have changed it, so it is working. Otherwise it is not mutable. Same goes with the list. If I want some list is there, suppose let's take an example, list equals to some numbers 10, 20, 30, 40. Okay, now I want to change it. I want to append, or I want to changing I have shown in the previous. I want to append equals to append 4. So what will happen, let's see. And if I use print list, so the new list is 10, 20, 30, 40 and 4. Append is append. By append function we can add the element at the last of list. All these functions we will be covering in the chapter list, so don't be panic. List, dictionary and set are mutable. Now when we talk about Python is an object oriented language. Python calls every entity that stores any value or any type of data as an object. An object is an entity that can have certain properties and that exhibit a certain type of behavior, that is, its value can hold whole numbers and have infinite precision, that is property. They support all arithmetic operations, so they are behavior. Every Python object have 3 keys. One is type, value and ID. Now type is going to give you the type of value which is stored there. Value is the actual value and ID is the physical address of that. So if we talk about, let's take few cases and I will be explaining that way. So if I write a equals to 15, so and I want print type, type of A, so it is going to give me 15. It is it is going to give me the type of A. What is the type of A? The type of A is, you can say, int. If I want the value to be printed, so simply I have to write, you can say, A giving 15. Even if you are displaying only number also, it is going to give 15. Now when we are talking about, we can pass type, or we can even pass function, and then we can pass literals also, so it is going to give type as string. Now the next one is printing the ID. Now what exactly is ID? ID is the physical address where the value is stored. So let's take print ID of variable A. It is giving some physical address. Now if I want to print, what is the value of A? The value of A is 15. So let's try for the ID of 15. It is giving same. So the ID of 15 and ID of variable A is nothing but it is referring there. Reference is there. So it is giving the same value in both the cases. So I'm repeating all the three things. Type of object determines the operation that can be performed on the object. And type is a built-in function to return the type of object. The second one is value. Value is nothing but the data item contained in the object. For a literal, the value is the literal itself. I have used here literal 15, so it is the value. You can say it's the value itself. Print 15, so it is value itself. And for a variable, identify the value of the data item is currently displayed. So I have used here print A. So in this case, the value of this variable is displayed, which is referring. Using print function, you can display the value of an object. So I have shown you the print also. Next one is ID. It is formally the memory location. The ID function of a variable is same as the ID of a value of it is storing. So here we have used ID A and we have used ID 15. It is giving the same value to us. Now the next one is operators. Now operators, there are many types of operators in you can say Python: arithmetic, relational, logical, identity, bitwise, assignment, and membership. We will be going to go through all one by one. Now addition, I will be showing you all with the example. So addition is simple. It is going to add two values. 15, suppose 15 plus 23, if I write, it is giving 55. Even I can go with the variable also. We have used some variables in the statement till now, so it is giving A plus B is minus 10. So have we assigned somewhere value of A? B. A, we know that A is what? 10. Have we assigned some value of B also? There is B is minus 15. So 10 minus 15. So we are adding 10 and minus 15. So we are getting, 10 and minus 25, we are getting minus 10. Same can be here, A minus B. So it is giving 10 minus 25. Minus 25 become plus. So 10. Now the value of A is what? Is still 10. And it is giving you 40. How it is giving you 40? What is the value of 10? Let's print the value of A once again. What exactly the values are stored? 15 is the value of A. And what is the value of B? It will be clear to you. So the value of B is 25. So 15 minus 25, because we are doing minus and already minus B, the value of B is minus. So minus and minus will become plus. So it is 15 plus 25 is 40. Now we can go with the subtraction we have done. Multiplication is very easy. I think you know that also. Let's take A into B only. So it should give us 15 into 25 is 375 and one value is of negative, so we are getting negative. Now we can divide also. Print A by B. Okay, now there are two divisions. You are getting 0.6. Let me try first the other one, then I will be explaining what is different between both. Now it is giving you minus 1. The reason being, it is always the you can say smaller value. Numbers are decimal digits after decimal point are removed. So minus 0.6 and then it is going to give you minus 1. Let me try the other way. Print B by A. It will be more clear to you. So it is giving you minus 2. 25 by 15. So what is value of this is 15 and this is 25. So we are dividing 25 by 15. Let me take the positive values. I think you are getting confused with it. Let the value of A be 10 and let the value of B be 5. Print, okay, let me assign value of C also, C equals to 3. Now print A by C. You have divided 10 by 3, so you are getting 3.3333. Now if we try print A slash C, it is going to give you integer part only. This is clear because negative numbers, minus, bigger numbers are smaller in fact. That's why we were getting minus and this. Now the next one is modulus, and you can say exponent and the modulus operator. Now if I write print A modulus B or modulus C, it is going to give you remainder. We are dividing 10 by 3, so you are getting remainder as 1. The next one is exponent double star, that is A star star C. It means what? 10 to the power 3. So 10 into 10 into 10 is giving you 1000. So I have explained all the operators. Now these are relational operators. When we talk about the relational operators, you are going to get some values, true and false. It always gives the value true and false, and we are comparing. So if I compare print, you can say A greater than B. We have all the values true. The value of A is, what is the value of A? The value of A is 10 and the value of B is 5. So A is greater than B. If I try the other way, print A less than B, it is going to give us false. Then we can go with print A greater than equals to B, true, because greater than or equals to. Same way we go with print A less than equals to B, it should give us false. And we check for equality, we have double equal to sign. A equals to, suppose I try with this, it is going to give you true because the value of A is 10 and we are checking with whether the value of A equals to 10 or not. Last one, A not equals to 15 suppose. So the value of A is not equals to 15, so it is giving you true. I think all these are clear. Next one is logical operators. We have and, or, and not, and they combine relational expressions and then you get. So for AND case, there will be minimum 2 condition. Output will be true when both the conditions will be true. If any of the condition is false, output will be false and you will be getting answer as 0 or false. With the OR gate, again 2 conditions will be there. If any of the condition is true, you are going to get answer as true. And not is what? If condition is false, you are going to get true answer, and if condition is true, you are going to get false answer. Let me show some examples here also. So print, let's take A greater than B and A greater than C. It is giving you true because the value of A is what? 10, value of B is 5 and value of C is what? 3. So A is greater than B as well as A is greater than C. Okay, print A is less than B. This is false, but or A is greater than C. In this case, first one is false, but the second one is true. So again, we are getting true. If I try here and in this case, only in this case, if I try here or is giving any condition true means you are getting true. But if we are giving here, this condition is false, only this is true, so we are getting false answer. If I write print not A less than B. So A is not less than B, so you are going to get syntax error. Now what is the reason? I have put double twice, so it should have only one. These are the things which you have to be very particular about, and I'm trying to give you all such possible, let me try, possible cases where you may get out errors also. So I'm purposely trying for you so that you know how to go with. And if I write the same thing, print not A greater than B, the value of A is bigger than B, so it is going to give you what? False. I think all the logical operators are clear. Now we have, next one is identity operators. Now in this case we are going to check is whether the two variables are having same value, are they referring to the same object or not. So if I write A equals to 1, 2, 3, and if I write B equals to A, and if I write C equals to 1, 2, 3, and if I try print What should be answer? True. But if I write A is C, it is going to give false. The reason being, though the values of A and C are same, but they are different objects. We have assigned different values, so they are different objects. Next one is very interesting. It is going to use the bitwise operator. It means you will be using these operators. It will convert the numeric value into binary, and then it is going to convert. So one is AND, OR, exclusive NOR, and NOT. Let's try a few. If I say print 5 and 3, 5 and 3, it is going to give you 1. The reason being, let me show how to represent 5. We know that 5 is represented using 1, 0. You remember 1, 2, 4, 8, which we did in the binary number system. So 1, 0, 1 is 5, and that, let me show that has why this has 1. Okay, so I'm showing you, let me 5 and the other one is 3. What is the value for 3? 5 and 3. So 5 is 1, 0, 1, and 3 is this and this. If we make it, this is 0. If we make it AND, this is 0, because for AND we have what? 3 is this one. So it is 1 plus 1 is 1, and 0 plus 0 and 1 AND will be 0, and again here will be 0. So we are getting answer as 1. When we will try with the OR, so 5 is what? 1, 0, 1, and 3 is represented using 0, 1, 1, and for OR any of the 1 to be true. So this is true, this is true, and this is true. So we should get answer as 7. And when we do exclusive OR, this is for this operation, and exclusive OR is this thing. It means when inputs are not same, output will be true. So this is and this. So in this case, this is 0 and this is 1, because they are not same, and this is also 1, so they are not same. So 1, 2, 4. So add up the place values of these. So 4 plus 2 is 6. So if we write 5, 5 or 3, the answer should be 6. If we write 5 or 3, the answer will be 7. And for this we are getting answer as 1. Let me show you on this thing. Now if I write print 5 or 3, I'm getting 7. Print 5, 3. This is exclusive OR when the inputs are not 6. And the last one, print not of 5. Let's take an example. It is going to give you -6. I want to make it clear here. Now when we try print not of 0, you are going to get -1. Print not of 1, you are going to get -2. Print not of -1, you are going to get 0. So how it is going, I will tell you here also. Now let's take an example. I'm writing here only. So we have, let's take 0, 1, 2, 3 and 4. This side -1, -2, -3, -4. So when we are going with 0, we are getting inverse as 0. 1 will be, you will be getting 0. Okay, if you are giving, you can say 1 of this, you are getting minus. So when we are giving positive number, we are getting minus one number minus to that. So if you are giving 0, -1, if you are giving 1, you will get -2. If you are giving 2, you will be getting -3. If you are giving 3, you will be getting -4. And it goes the same way. If you are giving -2, you will be getting answer as 1. -3, you will be getting answer as 2. So it goes that way. So it is what we go with the, you can say bitwise not. And now last one is, what is expression? It is nothing but the combination of operators, literals and variables. So any expression you can write a plus, you can say 5. So this is what? This is plus is operator, this is literal, and this is literal, and this is variable. So this is variable, this is operator, and this is, so this makes one expression. So it can be arithmetic expression, it can be relational expression, logical string expression, it can be of any type. So that's all for this you can say session. Python has versatile data types. We know that operators allow various computations. We know that understanding mutability is a key, then expressions form the base of Python program. That's all from my side. If you have not subscribed this you can say channel, please do subscribe, because I keep giving you all the sessions related to your 11th and 12th IP as well as CS, and keep trying, keep coding, take care of your health. Let's meet in the next session. Till then, keep coding.